So what we've got here is a story that stitches together a number of different chunks, starting with what really happens out with the water utility, then through some sensors, transmitting some data over a wide area network, then getting it back to some sort of platform, and on that platform we can do some really clever statistical analysis and work, then integrate into a system of record, and then from there derive the correct behavior for both your engineers or the end consumers. And for some of the delegates, that's quite a big leap of faith to kind of stitch all the pieces together. So what we thought we'd do is, rather than do it through PowerPoint, we'd actually build a model. So what you're seeing here actually shows that whole story end to end.
So you're showcasing the Internet of Things capability, in effect.
It's not just the Internet of Things, it's the whole line through then to a platform as a service, and then the statistical backend, and the enterprise asset management, and then finally mobile endpoint.
Wonderful. Very impressive design, Rory. Can you show us the end-to-end story?
So what we have here are three different scenarios. So first of all, we're about to have a hideous chemical accident, and then we're going to have a burst water main, and then we're going to engage our customers in a conversation about their water usage. So all these sensors are collecting data, and under the cupboard here we've got a local Wi-Fi, and then via MQTT and then encrypted, it's going over the internet to our platform as a service Bluemix out in Dallas. So if you actually look up on the screen there, you'll see that all of these dials are running live. So at the top there you'll see there's two pH sensors which correspond to these two sensors here in the bucket. So I've got here a vial of hideous chemical goo. So we're about to have this terrible industrial accident. So here's a chemical spill somewhere in the river waterway, so here it goes. Now these sensors update about once every 10 to 15 seconds. So what you'll see shortly is the top left dial is actually going to start dropping pH. Now right now you can see that both sensors are detecting some acidity, but it hasn't matched a business rule that a pollution event has taken place. But you'll see very shortly there, it's now detected a pollution event. And if you can see in the small text, the Maximo work order, that's not a mock-up, that's not cosmetic, that's a legitimate full-blown Maximo work order integrated in by Node Red. And of course, the work order could be enriched with all of the data, the GIS, the enterprise asset management, and then can actually send a work ticket to the correct engineer. Now with all the bonus marks, would actually integrate that with a mobile endpoint. So this is also sending the same work order instructions to one of our engineers via their smartwatch. So I don't know whether we can maybe capture that. I think we've got that down as well. Here we go, our able cameraman is showing us that.
These are the pH sensors, Rory?
Yep, these are the two pH sensors, that's right. So that's the first scenario. So the second one is actually showing a leak in the water mains. Now, as you know, that non-revenue water or water leakage is typically about between 8 and 12% for the water industry. For the purpose of this model, we're going to do something slightly more catastrophic and show effectively a burst water main. So if you look here, we have these flow meters. So there's an upstream, a midstream, and a downstream meter. And these are actually being monitored and reported on. And if you look at the middle row of dials, you'll see that the flow rate there is all roughly stabilized and similar. And the orange band is a moving total. So it shows they've all been stable for some time now. So what I'm going to do now, Greg, is I'm going to simulate a burst water main by opening up this tap. So this is...
If I could do the honors?
It's a very stiff tap, but you're most welcome to. I wasn't kidding when I said it's a very stiff tap. So now that's open. So you'll see down here we have our water leaking out. And what this means is the upstream sensor is still going very fast, but the midstream and the downstream sensor are now completely stopped. And you'll see that actually reflected in the dials on the screen. And even though we don't actually show the text on the screen, a second Maximo work order has been created with an alert sent to the engineer. And it doesn't just generically say there's been a burst water main, it will also actually say, and we believe that it took place between the upstream and the midstream sensor, or I think it says just before sensor 2 is the actual language it uses. Okay?
Excellent. So let's fix the leak.
Let's fix the leak. That was it turned the right way, doesn't it? Okay, now the last example is actually simulating how the end consumer might interact with water and their smart meters. So here we've got two buildings with smart meters here, and these taps are just simulating their residential or industrial usage. So I'm going to just start using some water. Okay? So you see here the smart meter is now flowing very quickly. What we've got disconnected through to, Greg, is a cumulative water consumption dial that's now counting up, just showing the total amount of water usage, and that will just keep counting to infinity. But of course, in the real world, that would actually be water usage within a particular period, say within a day or within a quarter. What we're doing here is we're saying this could be your normal water usage in the first thing in the morning, or it could also be you washing your car on a hard surface in the middle of the day during a hose pipe ban. Now, what we're experiencing is that most people are reasonably insensitive to their actual water bill. They don't pay a huge amount of attention to it, maybe only 5 minutes a year. And the amount of money that's actually charged on their bill is probably a bit below their real care threshold. So it sort of is what it is. And the problem with that is, how can I encourage you to do the right behavior? On the water bill, I would say to you, during a hosepipe ban, which you need to go and find out if there's one in effect, please don't use water between 10 a.m. and 4 p.m. Okay, but with a smart meter, you can actually extract hourly data or whenever you wish to poll your data, and then I can actually say, I know you're using water, it's during that period of the day, I know there's a hosepipe ban on, and through the weather company, you can even say, and I know it's a hot sunny day. You could even go so far as to say, you're watering your garden in the middle of the day, and I can even tell the forecast that it's going to rain in a couple of hours. Now, if you combine those ingredients together, it allows you to have a conversation with your customer, which isn't just a once a year, here's your bill. I could actually send you an alert saying, you know, you really shouldn't be watering your lawn now, and it's going to rain in a couple of hours, so I can actually drive the right behavior. So what we're really doing is, just as examples, just bringing together all the different bits and pieces to actually try and come up with an integrated solution, to help drive the right conversation with the customers and operate the utility in a more efficient way.
Wonderful, Rory. Thank you.
Thanks, Greg.